Hello, welcome to CESMII Studios and our broadcast of 6 Degrees of Smart Manufacturing. I am Conrad Leva.
And I'm Mike Yost.
And in this series, we cover the very different perspectives and topics on smart manufacturing from the many points of view of manufacturers, practitioners, engineers, integrators, consultants, educators, and researchers. The many people involved in this smart manufacturing journey. Today, we're having a 20-minute chat with our guest, Ethan Rogers from the DOE. And you can use the Q&A feature to send us questions. However, if we run out of time, we might have to answer those questions at our LinkedIn group conversation, and we will give you that link at the end of the show.
Thank you, Conrad, and welcome everybody. And before we bring Ethan on, just very quickly for those of you that are new to the concept, why we talk about 6 degrees of smart manufacturing. And it's based on the idea that we need to find the information that makes smart manufacturing a reality for all. And we think the best way to do that is to get people connected with people. And if we're only 6 degrees of separation away from knowing every person on the planet, that we should be able to get to the knowledge and get to the people who have experience and can share by connecting as many diverse people and with their unique perspectives as possible. So that's why this format exists the way that it does. And so we are excited to welcome Ethan Rogers, a physical scientist from the United States Department of Energy, the Advanced Manufacturing Office, or what's referred to as AMO. And we're going to be exploring opportunities for energy management and efficiency in smart manufacturing. So Ethan, if you want to turn your microphone and your camera on, you can join us here. Welcome, good sir.
Glad to be here. Thank you for inviting me on your show.
Excellent. Well, so everybody knows, as you can see from Ethan's bio, he has over 20 years of experience, specifically in the areas of industrial energy efficiency. He's worked in industry, government, as well as nonprofit organizations. And he's really a well-respected individual when it comes to this topic. And we've been having a conversation over the last several episodes about the tie from smart manufacturing into energy management, energy efficiency, energy savings. And so we found Ethan. He is a member of DOE, as mentioned before, and works with driving the understanding of energy management standards into programs that exist and into corporate sustainability standards and such. So we look forward to him deepening the conversation that we've started and driving things over the next 20 minutes or so. So, as I mentioned, we've had this conversation. We've been making the connection sort of on two fronts, from the work that we're doing from a smart manufacturing perspective and the impact from an energy management perspective, and then also that perspective from the plant level into the overall supply chain level. And so, Conrad, last time we used this illustration, this graphic, to frame up part of our conversation. So you want to start here and set the stage for us in pulling Ethan in.
Yeah. And so we were discussing last time this report coming out of some research that was sponsored by CESMII and UCLA. But when we were looking around for references on energy savings and smart manufacturing, Ethan's report called The Energy Savings Potential of Smart Manufacturing came up from when he was at the ACEEE. And in that report, Ethan, you have a figure 10 that makes some projections on energy savings, and we want to make sure that we understand the potential, because it's the why it's important to look at energy and industry. And I would like to get your thoughts. That was a few years back, and I would like to get your current thoughts on energy savings potential here in industry.
Certainly. Yeah, when I was at ACEEE, I ran the industrial energy efficiency research program, and we spent a lot of time looking at intelligent efficiency, which, you know, smart manufacturing is a subset. And the reports that I wrote tried to describe for people new to it what it is, what the features and benefits of it were, and then in an effort to give them a reason to care, we did some kind of rough economic analysis on what the potential energy savings would be from these investments. And in one report, we did a projection for what it would be if we were to increase the incentives for investments in intelligent efficiency for the commercial sector and also for the industrial sector. And our prediction was that you would save billions and billions of dollars of extra money in energy costs and other savings, but I think we focused just on energy costs. If we were to goose the economy and increase investments and accelerate investments in smart manufacturing, we didn't have a whole lot of data to go with when we made these predictions. I would have loved to have had this report. You know, I searched high and low to try and find some data. It's like, so what would be the average energy savings that a manufacturing facility might have if they were to invest in smart manufacturing? And, you know, there was at best breadcrumbs for me to do this broad-based economic analysis from. So I really appreciate that you guys have come up with this report. It's about 5 years too late for me, but I'm sure it's useful for other people.
Yes,
Well, but you do have a lot of interesting information in that report about the mechanism and the rationale about how these things come together.
Yeah. Yeah, we really wanted to try and paint for people a picture of how this all worked. And, you know, for the uninitiated, like myself, in the area of intelligent efficiency, there's an awful lot of acronyms. It's a real acronym-rich environment. You can get into manufacturing of ERPs and, you know, all these different acronyms. And so it's like, how is this all going to connect? And we wanted to, you know, you're showing one of the, on the right is one of the graphics we have, and I think you've enhanced it with some additional graphics, is, you know, what is the relationship between the different components? How's the information flowing? Why do you need this information? Who's using this information? What's it being used for? And so we tried our best to explain both, you know, with our text and with our graphics, how this information is going to save energy, translate into save energy. It's kind of the macro version of adding more meters to your facility doesn't necessarily save energy. The meters don't save energy, but by the information you get from those meters, you can save energy. And sometimes that's a very difficult discussion to have with your purchasing people. Say, oh yeah, I want to spend thousands of dollars on meters. Why? Because I'll know more. Well, what do you need to know more? So I can save money. And so I think smart manufacturing is, you know, a logarithmically bigger version of that conundrum.
Oh, and it is a conundrum. I mean, we live with that all the time as far as, you know, it's not just the information, it's what you do with it. It's how you change behavior, et cetera.
Right.
Why don't we flip back? So Conrad sort of threw a curveball at you. So Conrad, why don't you make the connection here from the CESMII perspective, where Ethan's going? We agree that this illustration, this report definitely plays into our focus.
Well, yeah, we feel that illustration there on the top right that came out of that report is actually still today at the center of what CESMII is working on, right? The connection is that data analysis enabled by smart manufacturing, that optimization and predictive modeling in smart manufacturing is how we increase efficiency and the use of all resources, and how we effectively reduce waste. So we're directly impacting energy usage as an ingredient, but indirectly also through the reduction of wasted resources in over processing, over production, over inventory, over transportation. So there's a lot of energy to be saved along the way. So that's the connection.
Mm-hmm.
Yeah.
And Ethan, I think there's another great story to tell around another diagram in your report. And this is a story of how this amplifies. So when you go from the process layer to the other layers in the manufacturing enterprise, and maybe you can tell us a little bit about that.
Yeah, so I tend to visualize things either in Sankey diagrams or Venn diagrams. If I can't break it down to that, I'm not sure I fully understand it. And this is one of my the Venn diagrams that allowed me, and hopefully allowed the readers of the report, to understand what it was we were talking about. And I think most people understand the efficiencies that can be gained in a device, right? I mean, that's pretty simple. You got a more efficient light bulb. It uses less energy. And, you know, for a process, you know, you might have a water pumping process, you know, they can kind of get the sense that if you run that more efficiently, okay. But as you expand further out, these energy savings become more disparate, and the parts of an organization that are involved in them become less connected. I remember when I was at the Purdue Technical Systems program, we were developing a green worker training program. And this was back in the early 2000s. And there was a lot of discussion about, you know, what is a green worker? And, you know, for me, it was just a matter of training. I see procurement there, right? And it's like, if you've trained a person to procure, to essentially put out bids for only equipment that is energy efficient, or, you know, sustainably made, or whatever the variables you are, that, you know, procurement specialist becomes a green worker. And by extension becomes part of your effort to save energy. And so all of these different acronyms and names you see there, they're all opportunities to save energy. And as you expand from the enterprise, then your organization is dealing with its suppliers and, you know, the transportation companies. You know, you get involved in design for the environment, since you're involving, you know, a lot of the folks involved in that. And so it's all connected. I often like to refer to the idea that everything starts off as dirt, water, and air, and we add energy and ingenuity to it, and we add value, right? So everything kind of breaks down to that in manufacturing. And the variable cost of any product, manufactured product, can probably be distilled down to the amount of energy that's embedded in it. So the more ingenuity you add, the less energy you add. The more energy, you know, you add, the more cost you're adding. So all of these acronyms, all these titles here are all opportunities to, you know, use less energy with the application of more ingenuity.
We might have a new slogan there, Mike. How to go from dirt and water and energy to final product in an efficient way.
Yeah, it's interesting. I think this illustration does a great job of making the point that we've been working to make at the Institute, that, you know, driving manufacturing productivity drives energy productivity. And I think to your point about all the different acronyms that are here, all the different initiatives that are listed here, they oftentimes have a side benefit that's not the primary focus. So somebody may take a particular project for a reason. It might not be for energy as a specific focus, but there's an energy impact that comes with that. And we talk all the time about smart manufacturing being an and story. And one of the things that's really gripped us over the last 6 or 7 months is the supply chain resiliency conversation in response to COVID. Right. And so as we look at how can supply chains be more resilient, we're also looking at, as we do that, it's not too far afield from the mandate of CESMII to be helping manufacturers be more resilient and responsive to market drivers, because we're still going to be amplifying the energy savings that comes along with this. And so that's really been the arc we've been on over the last several months of even having these conversations. because it's important that we're doing both, and that we're, again, capturing or making people aware of the energy savings that go along with that.
And
Yeah, absolutely.
go ahead.
Go ahead, Conrad.
Well, I was going to say that even at the supply chain side, even the reshoring story reduces the energy footprint. So we're looking at reshoring for all kinds of good economy benefits, but there is energy reduction benefit also. So there's always a energy savings vector in a lot of these things.
Right.
When back in 2018, when discussions of blockchain were all the rage, I went down the rabbit hole to see what the energy potential savings might be. And what I discovered wasn't so much tied to blockchain, but the idea that you could, through this exchange of information, eliminate an awful lot of kind of administrative activities. And I think that this is a lot of what smart manufacturing and the broader intelligent efficiency thing can do, is that, if I might paraphrase Jim Davis, you have the right information at the right time being provided to the right person in the context that allows them to make the right decision, right? And so to me, that just really summarizes it, is that I think up to 20% of the cost of logistics is in the administrative and, like filling out paperwork and communicating information and things like that, right? And so if you can automate that, you can take that administrative cost out. You can take, and there's an energy savings there to be sure, right? It might be very difficult to determine, but obviously you're taking a lot of cost out, and you're probably reducing errors and things like that by automating it. And I think that is, through the supply chain, the real potential is the ability to communicate up and down the supply chain with all the partners and get them the information they need in a timely manner. The information they need right now and the information that they need to know about what's going to happen tomorrow or next week or next month. I think that is very powerful, because it allows people to, not waste time and energy now, and make decisions now that will enable them to not waste time and energy tomorrow. I mean, you think about the closed loop capability of smart manufacturing within like a continuous process of an oil petrochemical refinery. If they know what's going to be happening a week from now, they can make decisions today that will probably save them energy a week from now.
To that effect, the DOE has many programs that are working at all kinds of aspects of these different layers. And Ethan, maybe you can take some of those examples and relate them to some of this work the Department of Energy is doing in these different areas.
Well, certainly. So see, over on the right, you can see the Better Plants and Superior Energy Performance programs. I'm involved in those. Better Plants recognizes leadership in energy efficiency in the industrial sector. And so it's a nice way to, if your organization, you feel that you're a leader in energy efficiency, it's a great way to get recognition from the federal government for those activities. Superior Energy Performance is a measurement and verification protocol and a program built around that. It's for companies that have gone through the ISO 50001 energy management standard. You can go for additional credentialing by going for superior energy performance that says that the way you are measuring your energy savings, you're using this robust, rigorous way of doing it. I like to say that the 50001 standard says you can trust my energy management system. The superior energy performance standard says you can trust my energy savings numbers. So that's enough about my activities. You guys are familiar with CESMII. Remade is another one of the institutes that's focused on the recycling. And let's see if we have any of the other institutes there. We certainly have the new Cyber Institute down at Texas in Austin, University of Texas, Austin. eGrid is working on, of course, the modernization of the grid. And we talk about the interaction of organizations with their suppliers. Certainly, your utility is one of the suppliers. And we're now seeing bi-directional communications between organizations and their electric utilities. And so that grid of the future, Grid 2.0, is something that they're working on. The SBIR STTR program helps small businesses. They're also one of the pathways for the Technology Commercialization Fund, because we've got a big push. Our Office of Technology Transfer is responsible for taking all the great ideas that come out of the national labs like NREL and PNNL and they're in California, Berkeley, and getting them pushed out to the market. And so that's certainly one of the roles that DOE plays. Another thing that I'd like to call attention to is the high performance computing for manufacturing. We have all these supercomputers, they're crunching away on things that I don't pretend to understand, like what goes on inside of atoms and whatnot. But they're also helping companies figure out complex problems, So if you've got something that requires a lot more computing power than you have or are likely ever to get, you can work with the national labs, work with the supercomputers they have there. They can help you develop your code and everything to figure out what that unsolvable challenge is that you're trying to work out. So those are just a few of the things we got going on. It's a very big organization, and we exist to help America, do everything quicker, better, faster, cheaper.
And there's definitely a potential connection here to CESMII of a lot of these things, because access, we're democratizing smart manufacturing, giving more access through the platform, and some of the things we can give access to is some of this work happening in AI and hypercomputing that could be leveraged through the platform for manufacturing.
Right. Well, gentlemen, we are at our time here. If there's any final points here on the any specific programs we want to delve into, I think this has been a fantastic conversation, and apologize that the time goes so quickly for us. But anything specifically from either of you on the existing programs we have here?
The time certainly did go quickly. I thought we had another 3 or 4 minutes. I just wanted to thank you guys for having me on your show again. This has been a wonderful conversation, and I encourage people to engage CESMII and the other institutes, as well as the different offices within energy efficiency, renewable energy, and the broader Department of Energy. Again, we exist to help the American economy.
Well, fantastic. Appreciate that. And just I guess to bring us back and close out, I think I'd just make a call to action along the lines of what Ethan just said, to engage with us and engage with CESMII, and we can engage with Ethan and those programs through the Department of Energy, and connect the dots there. Conrad, you look like you wanted to say something. Did I cut you off, or you?
Yeah, well, I was going to say that, I wish I had done better in thermodynamics in my university class, but look at us now talking about energy. And I think, every time it's important to remember the laws of thermodynamics, and that every time we use energy to create something, we lose some along the way, and that we're all about trying to waste as little as possible and still get that end product.
Absolutely.
No, fantastic. I'm not going to go back and forth on the laws of thermodynamics, so we'll just close us out of here. And as Conrad said at the beginning, encourage everybody to join CESMII's LinkedIn group. It's a private group, but we will let you in if you're willing to be part of these conversations. We will post links to this recorded session on our website, in the LinkedIn group, and on our YouTube channel. So I encourage everybody to get involved and stay involved.
And we have some exciting more episodes coming up. We're going to have Joe Kufi from Penn State joining us and talking about modeling and optimizing energy usage with Fred with their with their extrusion device, and that will be a fun session. And then we are going to move on and talk about the connected worker or the connected workforce more generally. And we will close the year with some interesting episodes, throwback Thanksgiving in our look ahead episode for 2021. So please stay tuned to our future episodes.
Yeah, so with that, we will bid everybody farewell. Thank you for a great conversation, Ethan, Conrad. Wish
Thank you.
a great day.
Thank you.
Take care, everybody.
Bye.
Bye-bye.